we're going to express a percent as a fraction or a mixed number depending on the situation. Let's go ahead and take a look at a couple examples. Excuse me. So if we've got a percent, I don't know, something like 16%, and we want to make that into a fraction, well, remember that 16% as a decimal would be written as 0.16. Okay. Now, if I multiplied the numerator and the denominator by 100, okay, so if I multiply the top and the bottom here by 100, so this we could put this as over 1. So if I multiply top and bottom by 100, what that's going to do is it's going to move the decimal place over, okay, twice, and I'm going to get it over 100. So what it'll do is it'll give me 16 over 100. Now, no one really does this step right here. What we do is we take a look at 16, and as a percent, we know that it is going to be 16 over 100. So really in our head, we go right from here to here. But you can think about this kind of as the middle step of what's going on. So we get 16 over 100, and typically we want to go ahead and reduce that. And so they're both probably divisible by more than 2, but I know they're definitely both divisible by 2. I can do this a couple different ways. I can just keep dividing by numbers until I reduce it to what I want, or I can look at the prime factorization. So what I'm going to do is I'm just going to say, well, they're both divisible by 2, so that would give me an 8 over 50. They're both divisible by 2 again because they're even, so that would give me a 4 over a 25. And now when I get to here, 4 is only divisible by 2 and 2, and 25 is only divisible by 5 and 5. They're both perfect squares there. So I'm done. I can't go anymore. And this is going to be a proper fraction. Okay. If it wasn't proper, we would go ahead and we would put it in as a mixed number, probably, depending on what they were asking for. So what we know is that 16% as a fraction is 4 over 25. So we could interpret this as if 16% of a class is absent, and our class was made out of 25 students, that means 4 of them were gone. Okay, so that's one interpretation of it. Okay, let's go ahead and take a look at another example. So let's say I've got something like, I don't know, 24%. Well, I'll leave this to you if you want to do it, but I know that this is going to be 24 over 100. And instead of just dividing by 2 every time, what I'm going to do this time is I'm going to take a look at the prime factorization. So let me just kind of do that over here. Well, let's do it over here as kind of some side work. So 24 can be broken down into 4 and 6. 4 can be broken down into 2 and 2. And of course, 6 can be broken down into 2 and 3. So what I've got for my numerator is I've got 2 times 2 times 2 times 3 for its unique prime factorization. Now 100, once you've done it once, you've got it done for all the problems if your denominator is 100. So, but we'll go ahead and we'll do it out one time. I didn't leave myself quite enough space here at the edge of the paper, so I'm gonna go ahead and I'm gonna just do it over here. Okay, so I've got 100. Break that down. We could do something like 25 and 4, which means this is a 5, a 5, a 2, and a 2. So that works. And so we've got our numbers there. And so I'm going to write them in order here. I'm going to go 2, 2, 5, 5. And we know that we can cancel these out. And so we've got a 2 times 3 on the top, which is going to be a 6. 5 times 5 on the bottom, which will be a 25. Now you might say, oh, is the denominator always going to be 25? No. the answer is that it's not always going to be 25. It just happened to be in these two examples. Okay, now we could go with something that is a lot larger as a percent. So we could say, what if we had 360%? Okay, what would that be? Well, that would be 360 over 100. Now we could leave it like this, but what I want you to notice, and we could go ahead and reduce, okay? But what I want you to notice is that it's going to be very quick to take this as a 36 over 10 instead of 360 over 100. They're both divisible by 10 right away. So I'm going to do that. So I'm going to say, okay, this is 36 over 10. Now I can see the answer already as a fraction here, but I'll just go ahead and keep dividing out. Now again, I would have had 360. I would have could have done a prime factorization of it, or I can keep going from here. I know that I can break this down. I like to continue to break this down as much as I can. So you can make this into a mixed number right away, right here, if you wanted to. I'm gonna just keep going with the fraction, and I'm gonna say, okay, well, they're both divisible by 2, so I believe that's 18 over 5. So we know that 5 goes into 18 3 times, right? And we have a remainder of 3 over 5. And we can always compare that on like a calculator or whatever to this to make sure that, yes, they actually are the same. Okay. We could also do something very small. So I did something very large. Let's do an example of something real small, and then we'll kind of end there. Let's say I had 3.21%. Okay, pretty small percentage. But this could maybe be like if you were looking at putting money into like a savings account. You probably, in a normal savings account, you wouldn't get about 3% right now, but you might get close to 3% if you invested it into like a long-term CD, or depending on what the market is giving back, you might see gains like this currently. So what I'm going to do is I'm going to rewrite that as 3.21 over 100, right? Because I know that it's going to be this thing as a percent over 100. But I don't like having the decimal place up here. So I'm going to multiply top and bottom by 100. So I'm going to get 321 over 10,000. Okay. Now, we got to figure out if we can reduce this or not. So the thing that I know about 321 is that the numbers 3, 2, and 1 add up to 6, and 6 is a number that's divisible by 3. So I can use some divisibility rules to kind of check to see if 321 and this number, this 10,000, have anything in common. So this is only going to have 5s and 2s, I believe, in it. Okay, so I'm not seeing that it's going to be divisible by anything else. 321, like I said, I know it's divisible by 3, and I think that gives me 107 back out. So I think if I take 321 and divide it by 10,000, I'm just going to verify this here. I don't think that we can go ahead and reduce this fraction anymore. But maybe I'm wrong. But I think we're pretty reduced there. Okay. So if you end up with a decimal still in your numerator after you've changed to over, okay, especially with like small numbers, your denominator is just going to be very large. Okay. So that is how we express a percent as a fraction, or potentially a mixed number like we did here.